是有的，就是说啊，就是我们那个 pass 的那个分数线是60嘛，然后如果50以下是肯定要就是整门课重新 take，还是整个学期重读，我忘记了。反正和我也没什么关系，反正然后好像是整个学期重读吧，然后50到60之间，好像是比如说哪一门课，你50到60之间的话，你是得在将来的学期之内重修的，就比如说你万一就是说，如果有一门课我在50到60之间，然后因为我们是工程系的嘛。因为所以说一学期6门课基本上是排满，没有什么空间在正常的学期里面重修的，所以说有可能就要放到那个就是 co-op 一边上班的时候，一边上课这样子，就反正人肯定会更辛苦一点，但是基本上就是这么回事吧。但是如果说你实在是没办法，可能就得延迟毕业。应该
对啊，我的意思说，那可不可以申请 gap year 或 gap term 这种？就是说，这个 term 我 feel so tired，然后呢，我想申请 gap，可不可以？
gap year 也可，也 gap year gap term 应该也可以，但是反正我没看到身边的人这么干过。不
你们的
过呢，倒是有一个情况，就是能怎么操作呢？因为是这样的，我们滑铁卢，一共有6个 co-op term，但是呢，如果为了毕业的话，只要求完成5个 co-op term，然
啊，
后你要是比如说，要么是第一个没找到，或者说，或者说是就是比如说做着做着中间有一个想休息了。
嗯
对吧？然后你就是如果对之后的都有信心能找到的话，你也可
嗯
以就是说你 gap 掉一个 work term，这样子，反正休息休息，调整调整，
，OK，
嗯，对，差不
没没，
多是这么个情况。
所以你们的是 twelve months，是 make full use of the 12 months。
那确实。
嗯，我认识有一些多大的，他们这个4月份到9月份都没有任何事情，就是一个 complete vacation 就 joy。哇，我在想4个月的一个就 vacation，这也挺恐怖的。
对，是可能人状态给他给他那个完了，再待会儿再学习的话，接着调整。但是滑铁卢就喘不过气来，没什么办法。
行，没有问题了，sorry。嗯，没有，其实问的还挺楚了。好的，很好。那么现在就这是
OK OK，我们稍微再等一会儿，现在好像只有3个人到啦。再等一会儿。那反正，既然在等人，那么反正我们稍微闲聊一下吧。这样的，就是说我们你看我今天其实没有发更新的这个那个 notebook，这个的原因呢，是因为我们马上要开始这个 final project，所以说呢，我就没有更新新的 notebook。那么这个 final project 呢，最好我还没有来得及在那个 notebook 上面试，但是最好呢，就是说需要这个我们自己电脑上装 Python。好吧，自己电脑上装 Python，然后这个 VS Code 这个东西，反正我之前也介绍过，如果你们还没有开始装的话，赶紧装上，好吧？然后对，基本上是这样的。然后，我们需要用到的这个包啊，名字叫，就是因为我们是需要 GUI 嘛，然后我们需要这个包叫这个 TK Inter，好吧？然后这个包 安装教程在那，因为说实话，因为我这个东西吧，也挺久，也挺也不是刚装的，因为挺久之前装的，估计是，我也不知道我什么时候装上的，反正就装上了，好吧。对，然后基本上就是这样。对，基本上就是这样。然后这个包网上搜一下，叫那个 TK Inter。然后，如果说是 Python install 的话，最好用这个叫 PIP install，会比较方便吧。但是我没有一直没有找到那个叫什么，我们这个官方的这个网站啊。对啊，那这是他们的那个官方 document，好吧？你只要一查，比如说 TK Inter，然后找到就是 TK Inter，然后 Python，这样子的话，它就会告诉你，比如说都有这么乱七八糟个 function，然后都是干嘛的，怎么样，这样子，好吧？那其实呢，这个东西，看上去挺恐怖的，反正也是个新的包嘛。这确实是我们啊第一次来 deal with 这个一个新的这个module 吧，应该说是，呃，在 Python 里面，这个东西说是可以分成各种各样乱七八糟的 module，然后我们虽然课上没有讲，但是你们多多少少应该都有了解，这个东西呢叫 import，对吧？就是你多多少少能看到，这种语句。那这个 import 的概念呢，其实就是说，你把这个别人写好的 library 给它抄到你自己的，比如说某一个 Python file 里面去，对吧？那么这样子呢，就是说你可以用其他人已经写好的东西，然后然后来就是在那个的基础上再写你自己的东西，对吧？那你就不需要就是 building everything from base again，对吧？就是对吧？就是不需要再重复的去造轮子了，好吧？那其实这就是 Python 比较方便的那一点，好吧？OK，那嗯行4个，行那我们反正要不先开始，然后对，然后这就是那个需要的东西，我看一下啊，我看一下还有没有什么还需要什么特别的东西，嗯，PIL 这个包吧，这个包我建议大家也装一下，如果没有的话，建议大家也装一下，好吧？然后在这个 code 的过程当中，如果说是有什么问题的话，建议大家直接来问我，好吧？或者就是说，不管怎么样，把这个问题给它解决，好吧？好吧，那基本上就这么个情况，OK，All right，那么如果是这样的情况的话，行，那要不这样，我先给大家看一下吧，这个是 VS Code 的这个 command line，然后如果说我们需要就是写点 Python code 的话，最好是需要了解这个 command line 的。最我不知道大家都是用 Windows 还是用那个 Mac，但是Mac 的话，这个 command line 更加方便一点。 然后如果是 Windows 的话，反正我个人用起来不是很顺手，说实话。好吧，那 Python 3 那么我们现在基本上要做的一个成品呢，就是这样啊，可能说是不太好啊，目前可能说是还是不太好看，但是说实话啊，我也没有空在做这个美工的东西，乱七八糟的。如果大家同学们有心的话，那可以自己学了这个包啊，然后呢。在自己在那个在这个 project 的这个基础上，再给它再做更加多的完善，好吧？那我在这里呢，并不会做的那种 super 详细，但是呢，主要说实话，美工这一方面啊，说实话也不是我们程序员要干的事情，或者说怎么说呢，也不是我们程序员主要干的事情，对吧？我们程序员呢，说实话，也就是做一个，就是它是后台的东西。不过有些做 front end 的同学们，不要被我冒犯到，好吧？希望不要被我冒犯到。front end 的可能更多的会有一些设计的这个方式。当然了，也比如说，也有些人确实挺喜欢 front end 的，我个人不是特别喜欢，反正觉得怎么说呢，缺点意思，缺点意思，好吧？那么怎么说呢？各有各的长处，对吧？各有各的好处。有人确实就喜欢就是 deal with 这种 graphic 的东西，有人更喜欢看 code。说实话，那这基本上就是我们的一个成品，好吧？目前背景上看上去还是比较怎么说呢，有一点 empty，好吧？如果同学们有心自己加，那么比如说我们现在这些个 button，对吧？这些个 button，比如说你 add 一个 student 之后，你大概就是可以填这么些个内容，对吧？这些是需要你填写这么些个内容，来让你的这个 student info list 更加的丰满，对吧？你可以 update student，对吧？比如说我现在点到某一个人之后，我需要我可以把它 update 掉，对吧？可以干某些乱七八糟的事情，然后可以把它 update 掉，OK。然后对，诶，这里其中有可能是个 typo，对，有可能是个 typo，好吧。然后比如说你要 delete student 的时候，对吧？然后他会给你一个 confirm，然后如果说你要那个的话，你就 successfully delete，对吧？那基本上就是这么样一个功能，对吧？你看看这种功能，说实话，我刚刚开始在这个 project 之前的时候，我感觉它挺简单，挺 straightforward，但是你真的要自己去操作，自己去把这个 UI 这些底层的 code 代码的逻辑给它撸清楚，其实还是挺有难度的，或者说是一个挺费神的东西，好吧？那么也就意味着这个东西其实操作起来并不是那么的简单，所以如果说大家有地方不清楚，或者说需要更多的解释，那也是很正常的事情，好吧？大家 feel free 来在这个 chat 里面跟我 interact，或者说stop 一下，然后让我 elaborate something more，OK？那在这个 teacher 这个部分吧，其实呢是一样的东西。那么这个事情呢，留给同学们课后作业，好吧？留给同学。当我在讲完当我在讲完这个 student 这一块之后然后啊、如果要到 teacher 这一块，你看我这边，说实话，我这边那个啥，诶。 有一些东西还是不是特别完善。反正我在过代码的时候，如果看到什么东西不大对的，我直接给它改掉就行，好吧？那对，大体上逻辑还是没有什么问题。对，好，那么在 teacher 这一块呢，我这边目前还没有 implement，这个呢是我故意留出来给同学们，在我讲完这个 student 之后啊，再自己重新把这个 teacher 这边写一写，基本上是差不多的东西，好吧？基本上没有什么太大区别。Will that be our final project? Yes. Yes. So that is the final project that we are talking about. And yeah, so this final project, I will guide you through this part. So the student part, right? And then for the teacher part, you will need to implement for yourself. But it is what I can say is it is very similar to the student part, as long as you make a few, small changes. But yeah, I don't have it, you know, I don't have it written out for you, so you are supposed to like try to do it yourself, right? And the most learning comes from studying it from yourself, or like the most learning comes from writing code yourself. Okay, so yeah, this is just a brief review of the final project. Brief overview, I would say, about the final project that we're gonna use, that we're gonna deal with. Okay, so yeah, enough about that. Um, let's actually first deal with those notebooks. Okay, those notebooks. There's still something that I did not finish on Friday, right? So yeah. Anyways, some more administrative part. So after we finish notebook, we do the project, right? And then after we are done with the project, then there is another topic called topics in computer science, which is for those ones who needs credit. And then you're supposed to like have a generation a presentation, sorry, a presentation to like sort of prepared and to get um, to present on a topic in computer science that you're interested in and know more about it. Okay, so and then hopefully we can end this entire course by the end of this week. I hope that it is somewhere near that. um, I think we should be able to finish this final project within a week. But yeah, we will just deal with it as we go on. Okay, so yeah, let's actually go ahead and review it. On Friday, we talked about this balanced brackets, right? So it is basically the idea of using a stack, and then you sort of just push on those left brackets, and every time you see a right bracket, and then you check your stack, right? If on the top of the stack, if those two bracket matches, then pop it out, right? Right. So current character is to yeah. So yeah, I mean, you just pop it out first, right? And then you just check whether this character is a small bracket, large bracket, curly bracket. Anyway, that doesn't matter how you say it, but this is just the symbol, and then this square bracket, right? So if those are those three kind of brackets, then if the character that you're currently half is not the right part of each bracket, then you would return false because it is not matching, right? And then the last case will be if the stack, if after all the string, after you go through in the entire string, if there is still stuff left in the stack, then you will return false as well, right? Because there will be unmatched left half of the brackets, right? And that's not something we want. So uh, that will return false as well. And then if those cases are all of those cases are not true, then we are returning true because we go through the entire thing, the stack is empty, and then everything is matched, so it is good. Okay, so that is how you deal with stack. Recommend you to write it yourself because it is the most, I would say, the most basic assignment um, in, I would say, uh, in the topic of stack. And this is actually in one of our assignments in our first year programming course in university. But even though it is just the fact that we use C++, but this is Python. So there's nothing too much difference on this. So yeah, that will be something useful to get yourself practice and remember how to do it. Right, and then binary search. Binary search is just another very important topic. The person who does not know binary search cannot actually be a good librarian, right? Since we have a joke about this librarian. But yeah, I'm not gonna play this video, but the idea is if you have a sorted array, or I mean, yeah, in this case, it's a sorted array. There will be more use cases if there's one different thing among lots of same things, right? Like suppose that you have a whole bunch of water, whole bunch of cup of water, right? And one of the is poisonous, and then it looks exactly the same as the other water, right? So that will also be a use case for a binary search, right? So like 1,000 cup of water or something like that. But yeah, that's the idea. So if you have a large array, and then you have a element that you want to find, then what you will need to do is you first have a value for low, and then you have a value for high, and then you're sort of having a mid, right? And then low and high are just the range of indexes you want to check, right? And then while low is less or equal to high, right, mid is equal to the integer division of the sum of low and high, and then divided by 2, right? And then you just searched up a mid number, right? And then you just check the mid number, use this mid number as a pivot, right? And then after you use it as a pivot, then you just sort of compare whether the number you want to find is larger than or less than this pivot, right? If the pivot is less than x, if pivot is less than x, then you are going for the right side, right? So you change the low to mid plus 1, right? And then if this pivot is larger than x, And then since you know the entire array is sorted, then you're moving this, you're going for the left part, left half, right? And then ignore the right half. So you're just changing the high into mid minus 1, right? Else, if you find it, then just return. And then that is basically how the algorithm is. The idea is pretty simple. And then the execution, there might be some details to check, especially I would say the most I would say the most tricky part is to figure out the index for mid and then this while loop condition. Okay, so yeah, this while loop condition and then this mid. All right. Anyways, I will leave this for you guys to practice and then to play with it yourself. Okay, so that is the binary search. Lecture 13. So we talked about merge sort, right? And then the idea is it actually uses recursion. It first keeps breaking the array into two parts, right? And then break it into two, and then until you break and then you do it until you break it into individual elements, right? And then in that way, what we can do is we sort of merge it, right? The merging, the way you merge is the way you sort. That is why it's called the merge sort, right? So when you try to merge it, then you can do this, and then because you have this 27, you have this 38, then you're basically comparing, like you have a pointer pointing here, you have a index or whatever pointing here, and then you have this, you sort of just compare those two numbers, right? And then after you compare, you put the smaller in the front, and then you put the larger in the later one, right? And then you do this for the same. And then for when each of them have two elements, then you sort of just pointing to the first element for the both, and then compare, and then sort of move this pointer to the next after you actually decide to merge it into the larger array. And then you just keep merging and merging and keep breaking up again, like you're just breaking up here. So yeah, just a reminder for this order. So it actually goes deep, right? And then it goes deeper and deeper and goes up again, and then it goes deep, and then finally it merge, right? So if you cannot see this, low equals mid plus 1. Okay. Okay. After I finish this merge sort, I will go back. I will go back to this binary search. Someone have a question about that. But yeah. So in terms of merge sort, so if you have this length of array as larger than 1, means that you have not yet break it into individual elements, then you have a mid, which is length of array divided by 2, which gives you the mid index, right? And then you just sort of break it into two part. L is equal to array, and then column mid, right? And R is equal to array mid column, right? So it actually divided into two halves, right? And then it caused merge again. So it sort of caused this merge sort on this individual part that you actually break it up, right? So that is how you deal with it. Like 1, 2, and then 3 is this case, and then 4, right? Then 5. Okay, right. And then this is the merge step, right? And then one comment that I'm gonna make is that for this merge sort, for recursion, usually the recursive step is at the end of the program, or I would say at the end of the function. And that is called tail recursion, right? And every time you reach to the end, you do a recursive call. But in this case, it is not. It is basically doing the recursion first and then do the merge next, right? So that is something to be careful of. Okay, and then this is just the merging, right? This is sort of doing like when I is less than L and less than R. That means like it gets the common length of the L and the R, right? So like for example, L is 4, R is 3, then it will loop until like 3, right? The index 3, right? And then it just checks, right? This K is for the index of array, the AR, which is basically this merged array, right? So this larger array that you're gonna merge into, right? And then this left and the right are just the subarrays, right? And then after you do this, then you have you're just basically comparing and then appending the smaller one, right? And then for those two while loops, it just checks if any elements was left. If there is, then just append them all into the larger array, because what happens is that for each of the sub elements, for each of the left and the right, it is already sorted, right? It keeps sorted, and this idea is actually called divide and conquer. So it actually breaks into smaller problems, and by solving the smaller problem and finding a way to combine those smaller problem solution, and then so that you can get a solution for a larger problem. Okay, so that is how you think of divide and conquer. Okay, I don't actually need this print list function, but yeah, it is just there. But yeah, if you call merge sort on this array, then those are the outcomes, right? So if you go through, if you have the patience and go through this printing, then you will understand this so much better. Okay, yeah, I actually closed this notebook. So lecture 12, right? So someone asked me about, where is it? Wait a second. Someone asked me about this. Let me check if that is correct. Low equals to mid plus 1 do. Okay, yeah. So those two are the same thing, right? So it is basically saying that you have, after you find a pivot, right? So array mid. So array mid will be something like this, right? Array mid is 2 and then 4, right? So if you have an index, and then in terms of that index, you will find a number, right? And in this case, this number is 4. But the number we're trying to find is 40, right? The number we're trying to find is 40. And that means that if you have a sorted array, you need to find the number 40, but currently you have this number 4, right? What do you need to do? Because this is a sorted array, so you will look deeper, right? You will look deeper to the right side, because you're currently on 4, but you'll need to find 40, right? So you are basically, change, like you're actually shrinking the size of elements that you need to look into, right? So this, let me annotate. So suppose that you have a list of, oops, looks ugly. Okay, suppose that you have a list of array, right? You have a list, right? So what you need to find is 40. Where is 40, right? Right now, you have a number here that is 4. Okay, so this is low. This is a high. This is mid, right? So after you first calculate it, mid right here is equal to 4. And then what do you need to do? Because 40 is somewhere here, right? I don't know where exactly it is, but I know it is somewhere on the right side of this mid index. So what you need to do is you make this low to the right of mid, right? So you basically iterate low equals to mid plus 1, right? Mid, yeah. So after you do the low is equal to mid plus 1, you're having a new low. And then, yeah, if it is on the right, if it's on the left side, then you will have a new high, right? But every time you do it, you're basically cutting the array by half, and then ignore 1/2 of the array, because 40 will be definitely not on the left side of the array, because on the left side of array everything is less than 4, but 40 is greater than 4, right? So you definitely need to look on the right side. Okay, so that is the reason we do low equals to mid plus 1. And then why plus 1? Because, oh yeah, that is another tricky thing, because you have already checked this mid, right? Because you're comparing this mid, and then if compare mid is equal to x, that is the else case, right? So you're already checked it, right? So you don't include that into this next index that you want to check, because don't do repeated work, right? So that is why low is equal to mid plus 1, right? And then basically after you've done it, then you're basically going to the next iteration of the loop, right? You're because after you do this, because this is a if else, right? Any case that you go into this or this, then after you go into this case, then you will go on to the another iteration, because there is nothing actually going on, nothing else that is going on in this while loop, right? So that is basically just if, else if, and else. And then you have a calculation for mid every time. Okay, so yeah, I hope that is clear enough. Yeah, once again, if you're not clear, then you can look at those printing statement, right? So changing low into 3, 7, right? And then you can actually, try to track. Okay, can yeah, got it now. So yeah, every time, like when you deal with algorithms, you can go ahead and print out, every key step that it actually does, right? So in this binary search, you just do like every time you iterate mid, then you just print it out. Every time you change from low, or every time you change high, you just print, right? And then after you do this so much printing, then you can actually go ahead and trace, right? What does it mean by trace? It just means that use your brain, or if you want to write it down, that's totally fine. And like go through each step of the code and then step by step, and then think yourself as a compiler, and what you will do using this and this, right? And then replace the numbers into it and actually checks the logic, and yeah, see what's going on, and then you will get better and better into those algorithm stuff. Okay, so yeah, that is also the case for merge sort. I have this very detailed printing statement, so I hope that you guys enjoyed it, and you guys can get yourself very familiar with this algorithm. And then yeah, time complexity. You don't have to really know this. That is university topic. I hope that the university professors explain this better, because they are so much high paid. But yeah, anyways, this is something that you can look at it yourself if you're interested. This is the mathy part of the coding, right? Someone might like it, someone might not. I'm not gonna force you to do it right now, because it is not grade 12 stuff. But yeah, that is just there for you to explore and try to study yourself if you have time. Okay. And yeah, I think you'll appreciate it in university when you actually go through this, and at least I would say at least get started, right? You might now feel like it is very difficult, and then when you actually do it in university, oh, I have seen this before, right? And then it might be easier for you to actually deal with those mathematical stuff. But yeah, that is the comment that I want to make. If you're really interested, search up those two. One is called recurrent tree method. The other is called master method. Those two are extremely helpful for recursion tree, and just to figure out the time complexity of a algorithm in general. Okay, yeah. So that is that. Okay, so after all this review, we're actually getting to this quick sort. Okay, so I would say that as a beginner, or as someone who never seen quick sort, I would say it is pretty tricky. Yeah, I would say it is pretty tricky. But once again, it is not very hard, like not extremely hard to understand. As you can see, this main code are composed of just two functions. One is called quicksort. Uh, you know, just again, this is sort of like a break at dividing and conquer as well, but in some format of different ways, right? And then one function is called quicksort, and one function is called partition. Okay, and then yeah, let's actually get into a video, and then to understand it better. So it is our favorite dance video, I think. Yeah.
Booking a trip can feel dramatic, but with
Yeah,
pre-cancellation, you can't go wrong with Hotels.com.
Just tell me what I need to know. Oops. Where is it?
Oops. Okay. Yeah, that's the real part. Ignore the ads. Yeah, all right. We finished this. So that is quick sort. I don't know if you guys have paid attention to this item hat, right? And this item hat is basically means that you know we are treating it as a pivot. So yeah, there's an idea, a new idea that is introduced in the quicksort. It is basically saying that we are choosing a pivot, right? So that pivot is sort of similar to binary search but different. That pivot is saying that every element that is uh, greater than me goes on my right, and then every element that is less than me goes on the left, right? And as you can see it here in the algorithm here. So there are, yeah, just one note that I'm going to tell you. If you look carefully in the video, you can see in the video it always treats the first elements as the pivot. Well, this algorithm actually treats the last element as pivot. There are no difference between those ones, but it is just saying that you know um, this is something that is chosen by the programmer. Yeah, and then there's there's a um, you can also choose it randomly, right? You can choose a random element from the array and as pivot that could sometimes be sometimes be better, right? And then yeah, so that is some notes that I want to make. But here, as we look into the graph, you can see this 70 is the pivot, right? And then everything is less than this pivot goes on the left. Everything is larger than the pivot goes on the right. And then for each of those, we choose this in this case 50 as pivot, then everything goes on. Yeah, so 50 goes on as a pivot. This everything is less than 50 goes on the left, larger than 50 goes on the right, and then 40 and then 30, right? And so on and so forth. And then this 80 and 90. Okay. So yeah, partition algorithm. There can be many ways to do partition. The follow pseudocode. Yeah, the pseudocode. I actually give you the full code, so ignore this. But yeah, the logic is simple. We start from the leftmost element and keep track of the smaller element, or equal to as I. When traversing, we find a smaller element. We swap with the current element. Array of I, and otherwise we ignore the current element. But yeah, this is again from the first element, and then we're choosing it from the last element. So it doesn't actually matter. Let's actually see the code. So we actually have this printing code, so we can just sort of you can actually just sort of we can actually just sort of go through the printing code. Okay, so first we have this element 10, 7, 8, 9, 1, 5, right? And then the first we'll call quick sort array, and then 0 and n minus 1, right? And that is because it is also having this idea of low and high, right? And then it actually deal with this kind of index, right? And yeah, so and once again, n minus 1 is just because the index of 5 is length minus 1, right? So if length of the array is 1, definitely not, this array is not 1. So if low is less than high, right? So if low remains less than high, then we are doing a partition, right? We're partitioning on array low and high, right? And then we go up into this function. So I is equal to low minus 1. Okay, so in this case, it will be -1. And that is pretty weird, but we are just gonna let that be. And we can tell it later, okay? And then pivot is equal to ARR high, which is why it says pivot is equal to 5. This is just printing. And then for J in range low to high, right? So that is basically saying that this J is equal to from low and then all the way up to high. And then that is getting this the index of low to high, right? And then the reason why that is not high plus 1, because you already have this pivot, right? So you only have to loop until one element before high, right? So that is why it is low to high instead of low to high plus 1, right? And then every time we loop, we print the array. Okay, so if the current element is smaller than or equal to the pivot, okay, if array of J is less or equal than the pivot, so we're first checking the array of array of j, in this case low, is 10, right? We're comparing 10 with 5. And then, yeah, so I will add another print statement here, comparing j and pivot. Okay, so that will make things more clear. Okay, so if I run this again, wait a while because notebook is not, yeah, so we have this array right now, and then we're comparing 10 and 5, and then it actually ignores because 10 is larger than 5, right? And then we're comparing 7 with 5, then comparing 8 with 5, and comparing 9 with 5. And then we are comparing 1 and 5. What happened is 1 is less than 5, right? And then that's is actually when we do the swap, right? So that is the first time we get into this if statement. We increment I, so to make I is equal to I plus 1. And since I is actually low minus 1, then after this plus 1, I will be 0, right? And then you're basically swapping the 0, which is the first element on the left, and then swapping it with this this number, which is the first number is 10, right? And then you're just swapping 10 with 1, right? And then you put it here, and then you put 10 is here, and then so that is the end of the for loop, right? So after you're done with the for loop, so I'll just print print and for loop placing pivot, right? So there's like placing the pivot. Okay, and after I run this, I also print swapping r plus 1 and okay, so that will make it extremely oops. Oh, forgot the column here. Forgot the comma here. Okay. Once again, forgot the comma here. Okay. Yeah. So it will make things extremely clear. So last time we will do this, right? So it is the end of the for loop, and then we will place the pivot. And then where do we place the pivot? We are swapping this I plus 1, which is the next element that is not, the next element after all the incrementation, right? So you're basically having this, you're incrementing this I when you find there is a element that is less than the pivot, right? And then after all this swapping, then you're just placing this pivot next to all the next to the left array, right? So left next to the left index, the left largest index, and then the next the next element that we want to swap is array high, right? And then that is basically saying that whatever is in originally in here, then you just move to whatever pivot that I choose, like the position. So in this case, it is the last element. Okay. And then if you have choose the first element as pivot, then you're just swapping with low or anything like or something like that, right? But yeah, that is the algorithm. That is the first run of the algorithm. Okay, and then return I plus 1. So why do we return I plus 1? That is a good question. What happens is I plus 1. What is I plus 1 equal to, right? What do I need to do is print call quick sort on array with low is low and high is this one, right? And then this is the same, but plus 1, and then high. Okay. So what happens is, after we're done with the partition, then you're having this pi is returned from this position, and then this pi is equal to, in this case, I is equal to number 2, right? Partition finished with pi equal to pi. So yeah, partition finished with pi equal to 1, right? Yeah, in this case, I plus 1. I is originally 0, right? So I plus 1 is equal to 1, right? And then that is the first pivot. Like that is the first that is the pivot location after the partition, right? And then you just throw that out to the quicksort function, and then yeah, quicksort on this with low is 0 and then high is 0, right? Because you're calling it from low and then pi minus 1, right? And then 1 minus 1 just equals to 0. And then since low and high are both 0, then what happened is for I in range, this function, it does nothing because it is basically ranging from 0, 0, and then because if you have a range 0 and 0, this will not go into the loop because on the right side 0 is not included, right? So it is basically like starting 0 to 0 is not included, so it's like 0 to -1, but like there's no such thing. It lists that means that in this partition, there is only one element, which means that this is done. Okay, and then with low is 2 and then high is 5, right? So it is basically saying that I have sorted this 1 and 5, right? And then we are starting from 8, right? And then all the way to this last one, 7, right? So the pivot is 7. We're comparing 8 and 7, right? So that is the first run of this this partition. That means that 8, this number 8 is compared with 7, and then comparing 8 is 8 and 7. 8 is larger than 7, then we don't do anything. In fact, everything is larger than 7, and then we just swap 7 with 8. Okay, and then this pivot. So the 7 is sorted, then the pivot is equal to 2, 0, 1, 2, right? So the 7 is placed here. Okay, and then there's nothing on the left. Low is 2, high is 1, don't do anything. And then that is again called quick sort on low is 3, and then high is 5, right? And then if you do low is 3 and high is 5, you choose the pivot 8. Then we do compare 9 and 8, you don't do anything. Compare 10 and 8, you don't do anything. And then you're just swapping 9 and 8. Then you're just swapping it here, right? And then the pivot is equal to 3, and then blah, blah, blah. And then you keep doing it until you swapped 9 and 10. And then finally you have this 10, and then the whole array is sorted. Okay, so that is how quicksort works. And one comment that I am going to make. Oh, I forgot to include the time analysis. But let me actually just quickly quick sort time complexity analysis. There's a Kahana Academy. There's a Wikipedia. I will just go for the Wikipedia here. So yeah, here's a portion for formal analysis. And then as you can see, in those cases, after here, like after you have this, and in fact this array is pretty bad for this quick sort. And the reason why is you're basically doing like every time you don't have anything on the left side or on the right side, and then you're just you can see there are a bunch of extra steps as you compare to like insertion sort on this particular array, right? And then sort of like, because sort of insertion sort does not have to compare so many times, and well, this is sort of like similar to insertion sort, where you just sort of just compare and swap and compare and swap, and it doesn't actually make this array better until the end. So there are a whole bunch of extra steps, and then because the reason why is this quick sort algorithm is not as stable as merge sort. Okay, so there will be some worst case. So as you can see in this in this Wikipedia page, this most unbalanced partition occurs when one sublist returned by the partition row is size n-1, right? So basically it means that you are choosing the pivot with the smallest or the largest element in the list, and then or there's another case that all of the elements are equal, right? So if that happens repeatedly in every partition, which means that for example, sort of you're choosing the you're having a sorted array, right? And then every time you choose the largest, you choose the last element, it will just be the largest element. And then the recursion tree is just very complicated. And in fact, the time takes n squared, right? But in a very balanced case, then it will only take on, right? This recursion is call process list of half of the size, and consequently we can only make log n partitions, right? So before we reach a size of 1, and then this call tree is log n, but no two calls at the same level to call blah blah blah. So times uses only n log n time, and then average case is also n log n. But just to be careful, for quicksort there is a worst case that can be as bad as n squared. So that is why I actually prefer merge sort a little bit than quicksort. But yeah, that's my personal preference. You can use it any way you like, and that is it for quicksort. Okay, so yeah, I hope that this huge amount of printing statement would make sense to you and help you to understand this algorithm better and better. Okay, so yeah, that is it for quicksort. And since this quicksort is more complicated, then I will give you like 10 minutes to sort of understand what is going on, why it needs so many cases. I can actually have a larger array, right? Feel free to try it with larger arrays and see what happens, right? So you can have 4, 29, and then 46, and then 31, then 53, and then blah blah blah. You can type a bunch of them. I'm just randomly clicking on my keyboard, right? Something like this, right? And I can have larger ones, right? And then you can have 45. Okay, so this will be a more balanced case because this is sort of random. I clicked it randomly. I I put my finger all across like 0 to 10, and then 0 to 0 to 1 to 0, right? So yeah, wow, that is a lot of stuff to do. Calling quicksort. Yeah, okay. Let's analyze this as well, or if you want to look at. But yeah, I figure that it is better to analyze this. If you have 45, right, and then compare 4, and then you are swapping 4 and 4. You're basically having this. So you just, if it's smaller, then you swap, right? And then if you compare 29 and 45, then you're swapping 29, 29 because you don't have to move anything. And then if you compare 46 with 45, then you don't have to do anything. Compare 31 with 45. 31 is less than 45, right? And then you have this I index is 46, and then you just sort of sort it here, right? 31 and 40, swap it here, 31 and 49, and then as long as it's larger than 45, don't do anything. Don't do anything. And then, you know, if you have 15 and 45, then you're swapping this 46 to this 15, because, you know, that is a way to keep left side less than 45 and right side larger than 45, right? So that is the case. And then, you know, just comparing 46, 23, and then you do the swap. And then 63, don't do anything, don't do anything, don't do anything. End of the loop, swapping the pivot. That is 82, that is 45. You swap it there, and then you start the next partition. Okay, so now I'm not gonna repeat myself. You know, if you want to, you can just copy my code, or, you know, copy my notebook and then do whatever you want, right? Nobody is actually having problem with that. So yeah. And then after you have this larger array, you can see this algorithm better, and then this performance is actually being better, right? So yeah, that is all I want to say about quicksort. So I'll give you until 30 to actually take that in, and then try to understand what is going on. Okay. And in the meantime, if you have any kind of questions, you can just let me know in the chat. All right, all right. I hope that you are getting familiar with this quick sort. And yeah, if you're not, then I suggest you to get more experienced with it after the class. Yeah, and then just look through those outputs, those printing statements to help you understand this better. But yeah, okay. Let's actually wait no more, and then I mean, definitely don't have time to finish this design project, but at least today, today we should get started. Okay, so I will code with you, even though I have the source code. But yeah, so as I have already already mentioned that I have already demonstrated you the code for I have already demonstrated you the code for this, and not the code, but the main GUI, and then how this final project works. Then we are gonna take a look at the data, right, and see how it goes. Okay, so those are a list of students and a list of teachers, and don't worry about it. I make all of those up using like a random name generator online. So I hope that coincidentally those are not real person. Okay, and then those are not real birthdays. Oops, I haven't changed the birthday for this. It doesn't matter. Yeah. So and then those are not real, but like those are just fake data that I make up, right? In the actual course, or the I don't know, maybe in your work you will be dealing with real data, but like that is something that you will need to learn by yourself. Okay, but yeah, so that is the data we're dealing with. The first for students, we will look specifically for student. There's a thing called student number, and then here is the student name, and then next is gender, female, male, and then date of birth, 1998, 1999, 1999, and then this phone number, and then this is the email. I made this up as well. Yeah. So this is the email. This is the program, which is the major. I'm assuming those are university kids. So yeah, those are email, and then this is enter date, which is the day that they enter university, right? Okay, so that is basically the data that we are dealing with, and then we have another text. For teacher. Then yeah, once again, they have a teacher ID that is pretty similar. We have we have the teacher's name, and then this is the same gender, date of birth, student number, not student number, but the phone number. This is email, but those two fields are different. So this field is what their title is. You know, there are professors, there are TAs, there are the dean, which is a faculty, like the president of the faculty, which is the dean. But yeah, those are just the titles, and then those are the schools that they're graduated. And there's an MIT TA just for fun. Stanford Dean, yeah, Waterloo, Toronto, and then yeah, don't be offended if your school is not on it. Uh, okay, but yeah, everything is just made up for fun. You can make up more. You can make up more. You can make up more fun. I would say you can make up more data if you want, but for now we're just gonna stick with those. Okay. And then they will be breaking into different parts, right? This entire program will be breaking into different parts. You can see here is a folder called data, right? So those are just the data that we are going to deal with. And then there is a folder called GUI, which is basically a folder that holds like everything for GUI, right? You know, it deals with like after you call this function Python 3 and then main GUI, you know, you can see this overall GUI interface. Yeah, GUI is called GUI, so I would just call GUI for short. So you can see this GUI, right? And then so that is a folder. It has some base detail and then student detail and teacher detail. Those files are for this when you add a student or update a student, then you will see a window, right? You will see a window pop up and then showing you those all the detailed information, and that is you know what is looking, right? So and then services. Um, so services, having these services are those services are just main files for I would say the backend of the structure or the logic for this entire thing, right? And then first you have this file operator, and then you know, you can have this class file operator, which you sort of just deals with those files, and then you know sort of read through the file, and then have the data there, right? And then you have person.py, which yeah, it is basically a class for person, right? And then sometimes it is easier to deal with it as a student object, right? And then you can also have this option for a teacher object if you actually want to build it yourself. That is an easy one. Here we are gonna talk about some abstract class. I have not included that in our object oriented units, but I will just briefly introduce it when we actually use it, okay? And then student service, this is the file that we actually want. Yeah, this is the methods that actually we're doing the service. You can see there's a thing called add, there's a thing called update, and there's a thing called delete, right? So it is basically like add, update, and delete. and then you have a function check as well. Okay, so that is the overall file structure of this. Okay, so for the logic and for in terms of the objects, you will have, so as I mentioned, this person, right? So this is a person class, and then the student class will extend the person class, and then continue from there, right? And then you can have a service class that is a abstract class, and then this student service actually just implements the service class and acts as a subclass as well, right? And then yeah, that is that. File operator just deal with the file, so it does not depend on anything. The base detail. The base detail is just for the window for. Let me actually give you an idea. So yeah, the base detail is just a detail, a framework, I would say, for this window, right? And then you know, just call if you call this function, then it will just give you you know, a base, and then the student detail and the teacher detail, those two files are extend, right? As you can see, this class here, class student detail, and then use base detail as a superclass, right? So that is basically means that you know, it extends from this base detail, right? And then continue from there. So it basically have whatever the base detail have, and then but have more stuff that you need to deal with. You can see those are pretty long code. Okay, so yeah, don't be scared. We can get through it, you know, slowly. Okay, and then there's a teacher detail. And yeah, I guess what we planned today is fairly easy. Go to this service and then add a class called person.py. What do we need to do? So we are creating a person, class person. That is fairly simple. And then we will have a def init. Yeah, so yeah, Visual Studio Code is just, I would say, easy to use. Not gonna sure if anyone else thinks, but I would just open my this file for reference. Okay, so in terms of person, the common thing for student and teacher is name, gender, birthday, phone number, email, and that's it. Okay, so you can do name, and then gender, and then phone number, phone, oops, and then email. Oh, and there's a birthday after gender. So birthday. Yeah, the order. In terms of order, it could be important, but could be not important as well, because you know, the order of this. If you decide to do positional argument, then you know, there's some sort of ordering that you need to figure out. But you know, it is better, like, because you have so many parameters, right? It is better if you use this, what is that called again? This parameter, parameter argument, which you say something like name is equal to name, right? So like something like that. So, but yeah, that's next story. But yeah, for a constructor, you just do self.name is equal to name, and then be civilized. We can actually copy paste, right? Okay, so self.gender is equal to gender, self.birthday is equal to birthday, self.phone is equal to phone, self.email is equal to email. Let me see if there is actually something more. So name, gender, birthday, phone, email. 5 fields: name, gender, birthday, phone, email. Okay, so that is basically it for this person class, right? Okay, and then this pass can be deleted. Okay, then well, you can leave it like this, and then you can also have a class, but you know what, I will just be better. I'll just be civilized and create a class called student, and then you do from person import star. What does star mean? Star means everything. Okay, so from person means you're importing a file from this class called person.py. Okay, and you can also do this from person import person. So this is basically specifically importing this person class. Okay, so that doesn't actually matter. You can do star. You can do you can specify whatever you want, and what you can do is class student. When you do classes, there's a naming convention for class to, there's a naming class convention for class to get for class to be like capital, right? As oops. Okay, so here, this IDE is too good. Okay, so init. What do you need to do? Self. One moment, please. Okay, so that doesn't seem to have any problem. Okay, pass. Okay, so yeah, for now we can just do pass. But yeah, what do we need to do? So it is extending the person class, right? So what do we need to do for the init function? First of all, we will definitely need to include name. So like basically you go here, copy all this, do this, right? As we learn from this what is it called, object-oriented unit, to extend a class, we need a constructor of all parameters. Like we need all parameters of the constructors of that class. Okay, so yeah, that is needed. Then what is extra? So student ID, right? So what you can do is just to make things in order, in case you like that, student ID, right? What else is in it? Student ID, and then major and enter date, right? So it is major, enter date, right? As a convention, you can use underscore I like use underscore more than camel case because underscore just makes things more clear. It is basically sort of a space, right? So it adds more space and makes your eye a little bit more comfortable. But yeah, what do you do? Super, right? So you're just calling the super class with its init function, and then you will need to pass in name. What you can also do is, if you want to do it more, name is equal to name, right? And then, oh yeah, look at this. This is good. So it actually gives you the hints for like whatever parameter is in there. So gender is equal to gender, right? Birthday is equal to birthday. Right? Phone is equal to phone. But right, if you have everything in order, you can just do like email, phone, like those. Like you can delete those as well, right? You can delete those as well. But I would just, to make things clear and make things less confusing to the users, right? And then you just have self.major is equal to major, right? And then self.enter date is equal to enter date, right? And then we delete the pass. That is basically it for this student class and person class. Why do we need this class? Okay, I mean, it is already stored in a list, right? The data is already stored in a list. We could use a list to do it. That is simple. That is, seems to be very easy to manipulate with it. But the problem is you will need to sort of use the index of a list, right? Think about it. Every time you do list, right, you will need to do index. For example, 1 or like 2, 3, or like 5 or something like that, right? And this is not very clear, right? You will need to ask, it will require you to remember all this, the order of those, right? I mean, this is only 7 fields, right? Imagine you have like 10 fields, 20 fields, lots of fields. How you're supposed to remember that, right? Like you can't do like list index and then index, right? To access like if it's female, if she or he is a female, male, or something like that, right? So that is very complicated to do. And then that is why we need this class to actually, this is called encapsulation, right? We have this idea, and then if you don't understand it well yet, then this is encapsulation. Basically, you are having a lot of information that is going on in your program, and then you're using a class to make like a pack, right? You're basically like packing it up in a garbage bag, not garbage bag, but like, in a plastic bag, let's say. That's a metaphor, but yeah, that is a plastic bag. And then you're just packing all of those information up so that you can access it real easy. You don't have to go into the lists. Okay, so that is that. I don't. Yeah, maybe we can go ahead and deal with this file operator class, and that is not too hard to implement. So let's do that. Okay. I don't know if we have time, enough time to finish all this, but I will just stop and then continue tomorrow. Okay. So in services, we will add a class called file operator. .py. What do I have here? Class file operator. Okay. Then what do I need to do here? Init. What do we init? There's not much that we need to init, but as you can see here, for a file operator, we will need a file path, right? Init. So none. That's default, right? And then we will need a path. What is that path? We can say student path, right? Self.student path is equal to, what is our student path? Dot means, yeah, I figured that you guys do not know this, but this is called relative path. And I would make the comment that the file path in Python is pretty much a headache, as far as I know. I don't know if you guys have more experience than me on this, but I would say that it is pretty much a headache, and you'll have to deal with it carefully. But if there is a problem, we solve it, right? So that is what we do. Okay. So this dot means go up in one folder, right? So currently this file is under services folder, right? And then we will go up one folder, basically hitting like the back sign. Okay, I will show you this. So we are to make things clear, we are at here, right? So we will hit the back button, go to here, and then find the student and the teacher, right? So this file path works like this. Dot means means go up one folder. This backslash, just a component of path. Right now we are in Python project in class, which is just a file, a directory that I made up. This is data. So we get into data folder, and then we go to student.txt. Okay, so that is the relative path. That is the path we need to use for student. Okay, so self.teacher path. So that is the same. Path equals to dot data that text teacher text. Okay, so after we are done, yeah, so I say file path, right? To read. What else do we need to do? So we can do a list, or we can do a person object that is anyways, that we don't have to be pretty strict. We can do anything. And as if right now we decide to put it into a list first. So you can do self dot. I'll just keep this name straight. So list student all. List student all equals to empty list, right? Because this is a definition, so you don't have to be. You don't have to. You cannot add anything, actually. Okay. So, and then what do we need to do? we need to call self dot this function called read from file. So we can write a function read from file. Okay. And then we can define a function read from file. And then we can do self. Okay, so what we'll need to do here is to read, to open this file from this file path, and then, sort of just get all of those information into a list. You can do it into a person object as well, but I am just not going to do it. I am just going to deal with as a list. Okay, so yeah, since time is up, I will leave this for tomorrow, and yeah, we will just deal with it slowly and slowly, step by step. Don't worry, we can go through this, and yeah, don't forget to turn in, don't forget to submit the assignment too. Yeah, it is actually due on yesterday, but yeah, just do submit the assignment. And yeah, that is basically everything for today's class. Is there any questions or concerns? Ask now. I will wait like 1 or 2 minutes, and then I will stop today. Okay, yeah, all right. Since no one actually have any questions, I will conclude this lecture. Hope that you get the quick sort and merge sort, and yeah, I will see you tomorrow. All right, I'll see you tomorrow at 10.
Thank
Okay.
you. Bye.
Yep. See you.
Good day.
See ya. All right. Let's stop.